Hey, what's going on, everybody? In my Calc 3 class, what's up? Here at Wayne State. Bear with me, this is the first time I've done this. My name is Everett, and Josie and I came up with this fairly mechanical way of reverse integration because a lot of us were having problems reversing the limits just by using the concept of it. It can be difficult to visualize the difference in the graph and get the limits correct. So this is number 39 in section 15.3. It's a fairly easy problem. The function and the limits of integration are fairly easy. But then again, the concepts of switching it, in drawing the graph and all that, it can be like kind of a pain. I know it was for me and some other people. That's why I'm doing this. Hopefully it'll help out, and we'll have to see what happens. See if you guys like it or not. Bear with me. I'm doing this by myself, so I'm trying to hold the camera and point and look at this and do that. Blah blah blah. All right. So the problem is 0 to 4, 0 to square root x, fxy, dy dx, and the problem said, sketch it and reverse it, but we're just going to reverse it because that's the hardest part. Pretty sure that you can draw this graph, so that shouldn't really be the problem. It's getting the limits correct after you do the, I keep saying reverse integration. I don't even know if that's correct. It's reversing the limits, So, all right. So what we came up with is this, all right? This sheet of paper over here is like gold. And I'm very humbled right now because Khan and Pat GMT on YouTube do a great job at this, and I am starting to understand why they have so much skill doing it, because they probably have so much practice doing this, like looking at it, like at the camera and doing this on the paper. Anyways, all right. So if this is the form, okay, dy dx that it's in, okay, then it's going to turn into this form here, okay? So whatever the limits of integration are, you assign a value. A, B, C, D, okay? dy dx, okay? This has got to be like, correct, okay? C is always the one with the variable in it. Very important to get that correct, okay? You'll see later on after you do a few of them that if you can get C right, it always corresponds, okay? If C is here, then A is here, D is here, B is here. If C is down here, okay, see here, if C is down here, then D, B, A. These never go over here, these never go over here, and if they do, it's they're going to I don't know what I'm trying to say. It's you'll understand it. I'm screwing this up, but anyways. So the problem was this, and we want to flip it. All right. So you got this. All right, and you assign A, B, C, D. A, B, C, D. There's two of them that end up showing up, an F and a G. Okay, these are strictly just letters that we chose to assign. Okay, it's this, and it turns into this. You don't even got to think about it. It's just, see these letters, you put the letters where they got to go, and you assign the letter value where each one corresponds. See, A is equal to 4, B is equal to 0, D is equal to 0, and C is equal to the square root of C, because it's always the one with the variable in it. All right? So for F, you plug A into C and solve. You simplify, okay? a equals 4. 4 goes into square root of x. Square root of 4 is obviously 2. Okay? So then f is going to end up equaling 2. See? F, oh my goodness, sorry. F and 2. See? So f always corresponds like with a. All right? You take a, you put c into it, and then it equals f. Okay? G is always going to be see, really up here, what this is this is the outer limit, this is the inner limit of integration, and this is the outer limit of integration, okay? So this one corresponds with this one, and this one corresponds with this one. Inners and the outers, they go together, all right? So you got the dy, okay? So y equals square root of x, and y equals 0, because the limits for y are from 0 to square root x, and the limits for x are 0 to 4. Okay? So now it's going to end up being switched. That's the whole point of this. See, dx, dy, dy, dx. So you start out with a problem, you assign the letter value, okay, in that order. You do this, you solve for f, which is a plug into c, you end up with the number 2. G is going to be square root of x equals y, so you solve for y, and y squared, equals x, obviously. You guys can see that. And that's it, dude. So it's F, A, D, G. So F is 2, A was 4 up here. See, you just put it there. D was 0, D was 0, 0, and G. G is y squared. G was square root x, which corresponds with this. Okay? So G kind of corresponds with C, and F kind of corresponds with A, if you want to think about it that way. All right? Now, that's the process. It's the same thinking, okay, for all of them. Okay? So number 1 corresponds with number 4, and 2 corresponds with 3. 1 turns into 4, and 2 turns into 3. Okay, see? See, C here is on the bottom. C here was on the top. Okay? So C, and then it's the one with the variable in it. So C is going to be the one with the variable in it. In either form, dx, dy, or dy, dx, it doesn't matter. It's A, B, C, D. A, B, C, D. Okay, if it's dx, dy, it's A, B, C, D. If it's dy, dx, it's A, B, C, D. This is the original problem. This is the original problem. Okay? If this was your original problem, then you do what we did before. You assign your letter values, okay, and then you solve for f and g, and then you plug it in, okay? So 1 turns into 4 because, see, it's dy dx, dx dy, okay? And these two, dx dy, turns into, it turns into this, okay? So 2 and 3 go together, and 1 and 4 to go together. I know I'm stumbling over my words a little bit. Forgive me. I'm trying to think. It's a fairly new concept to me too. So, but this is correct. It works for everyone except the semicircle problem, because it's something to do with the symmetrical, the symmetry in the semicircle. So that's it. That's all there is to it, man. You assign your letter values for whatever it is, and then you just turn it into the other one. So 1 turns into 4,